The data used in this following video were generated through artificial means. They are in no way related to the people portrayed in this video. Any correlations between the data and the actual public personas of the individuals mentioned in this video are strictly coincidental. Hello and welcome to the second part of the multivariate repeated measures analysis part of this series. For this video, we are going to discuss profile analysis. Now, for those of you who like my videos and find them helpful, please feel free to give me a thumbs up or subscribe to this channel. Now, in the previous video, I have talked about multivariate repeated measures analysis, how it is a wide topic within the multivariate statistical analysis area of statistics. There are three scenarios that are covered under this wide topic, and one of it is a scenario where we have multiple outcomes of interest, and for each of these outcome variables, there are only one measurement. And I also mentioned that under this scenario, the method that's best used to analyze this data set would be profile analysis. So the best way that we can talk about profile analysis and understanding exactly what it is by using an example. So let's say we have a scenario where aliens want to study the values and attitudes of the human race between different professions. Let's say if they want to ask the question of, do human belly dancers, politicians, and doctors share similar values in terms of power, money, physical appearance, and intelligence? If they want to ask this question, then we can use profile analysis to study the parallelism of the data set. Let's say if they have another question which is related to the first question, the question might be, do human belly dancers, politicians, and doctors each value power, money, appearance, and intelligence equally? In this case, we are using profile analysis to study the flatness of the profile of each of these professions to answer this question. Now, in this scenario, the outcome variables are the attitudes and values that these three professions assign to power, money, appearance, and intelligence. And each individual in this data set will have one measurement of each of these variables. So let's say if these aliens have a limited amount of resources allocated to how many humans they can actually abduct from planet Earth. Instead, they chose an example of each of these three professions from the human race. And let's say these aliens were watching TV and they saw Shakira and they thought she was the best example of a belly dancer. And they also saw Donald Trump and they thought he was the best example of a politician, which some people may not agree. And let's say for the third one, the doctor, they saw Dr. Phil and they thought he was the best example of human doctors. They decided to abduct these three people from Earth. And for each of these three people, they made 5 clones of each of them, and they implanted a chip inside of their brains to measure their attitudes for power, money, physical appearance, and intelligence. Then they placed these 15 clones into a simulation that resembled their real lives. And they measured their interest in power, money, appearance, and intelligence, and recorded these values as a number between 1 and 10. And they want to analyze this data set to see what are their values and how are they different between each other, and how do they view these values differently in each clone of the same type. And if we want to do that, let's say we already collected the data set, we use R in order to analyze these data sets. Okay, so let's say if these aliens also abducted you to analyze the data that they collected for them. Now, since you are an expert in R, you would know that in order to perform profile analysis, there's a package in R that can do this very quickly for you, and this package is called Profile R. So for those of you who haven't installed this package into RStudio yet, you can run this line to install this package. But if you already installed this package and you just want to open it and use it, use the library function to open this package. Great. So the next step, we read the data that was collected by the aliens using the chip that's implanted in the clone's brains. And we read this data into the R environment in the form of vectors. So power, we can read it in, money, appearance, and intelligence. And also, of course, we have to label these data by the names or by the types of clones. Like there are Shakira clones, Donald Trump clones, and Dr. Phil clones, and there were 5 clones each. So this is the repeat function. We enter the first entry as a vector of the different names for the different clone types, and for each name we had 5 clones, so the next vector that we enter into is a vector of 5, 5, 5. So 5 clones of Shakira, Donald Trump, and Dr. Phil each. So we just run this line. Now we use the data frame function to put the names, power, money, appearance, and intelligence vectors into a data frame. So we just run this line, and we assigned the name profile data to this data frame. So now we can open this data frame, and as you can see, we have the names of the clones in the first column, and we also have the values collected for their attitudes towards power, money, appearance, and intelligence. Now, using this PBG function within the Profile R package, we can easily perform the profile analysis for testing the parallelism as well as the flatness. And we can do this very easily by just one line of R code. Now, the first entry that we enter is the data frame, the profile data frame, but without the names column. So this line right here, we can remove the names column. So we use the function subset, and we enter the data frame that we want to work with here. And then we enter the select parameter, and we enter minus a vector with only the names column. So this minus means we take out the names column from the profile data. So we run this function here, and we assign the new data frame as profile without the name column. So if we were to look at this new data frame, we can see that the name column is now gone. So now the first entry, of course, is the data frame without the name column. The second entry is the name column that we removed just now. And we can take that name column from the profile data frame. And for original names parameter, we put true, and for profile.plot, which gives you the plot of the profiles for the 3 different types of clones, we also put true. So we run this function, and we assign the results to the name model. So we just run this line right here. Now, just by running this line, this function actually gives you a profile plot, so you don't have to build one by yourself. Now this one, you can see that the legend takes up too much space, and this function in this package is not exactly perfect, and this is part of its imperfections. The legend is blocking the graph itself, but not to worry. All you have to do is rerun the PBG function line that you had again, and it becomes smaller. It doesn't disappear completely. I mean, just run it a few times more and maybe it will become smaller and smaller, but it doesn't disappear completely. But not to worry, we can still work with this graph. Let's just run this a few times more. It becomes smaller, and that's about as small as it's gonna get. So if we were to look at this graph, and this graph is called a profile graph, and the reason is that it's called a profile graph is because these are the values, these dots right here, and these dots and these dots. These dots represents the mean attitude that all the Shakiras, like this green line right here, it represents all the Shakiras. These dots are the mean attitude that all the Shakiras have in terms of power, money, appearance, and intelligence. And this line right here is the Shakira clone's profile. And this red line right here is the profile of all the Dr. Phil clones. So it's the mean attitude of all the Dr. Phil So it's the mean profile of all the Dr. Phil clones and their attitudes towards power, money, appearance, and intelligence. And for this line, of course, it's the profile of all the Donald Trump clones, that is. And these are the mean interest for all the Donald Trumps for power, money, appearance, and intelligence. And for power, it's blocked by the legend. So let's just assume that it's a very high number right here. So from all these profiles, you can see that the lines, they have the tendency to cross each other. So therefore, from our naked eye, we can see that these lines are not parallel at all. And also we can see that these lines, they're not necessarily flat. Because look at this one, it goes from high to very low, and this one, it goes from low to high. Now, what this means is that when it's not parallel, it means that these 3 different people, they don't share the same level of interest for power, money, appearance, and intelligence, at least not in the same pattern and not in the same way. So that's what parallelism represent. But for the flatness, we can see that the lack of flatness, what it means is that these people, just among themselves, they also don't value power, money, appearance, and intelligence in the same way. And it's not just all the Trump clones, also the Dr. Phil clones. The clones don't value power and money the same way, and they don't value money and appearance the same way. And it's the same with the Shakira clones. So So as you can see that with our naked eye, we can see from this graph that none of these three types of clones have flat profiles, nor do they share parallel profiles. Now, some of you might say, April, we can't use just a graph to judge the profile of these three types of clones. We need to use statistics to do that. So if that's the case, we can also use statistics to prove that the profiles are not parallel, not in a statistical significant way, and also they are not flat in a statistically significant way. And what we do is we run the summary function on the model that we just built. There we go. So as we can see that there are 4 tests: Wilks, Pillai, Hotling, Lawley, and Roy. These 4 tests are used to test to see if there's a significant parallelism between the 3 types of clones. And as you can see that all the p-values are below 0.05. So at a 95% level, we can reject this null hypothesis, which says that profiles are all parallel, which means that the profiles are not parallel, which in turn means that the 3 types of clones do not share the same values for power, money, appearance, and intelligence in the same pattern. Now let's look at the test for flatness. From the test of flatness, we can see that the null hypothesis is that all the profiles are flat, which is another way of saying that Shakira, Dr. Phil, and Donald Trump, they each value power, money, appearance, and intelligence relatively equally. Now from this p-value, we can see that that's not true because the p-value is also below 0.05, which means we can also reject the null hypothesis that the profiles are flat. Now, what this means is that each of the 3 different types of clones, they do not value power, money, appearance, and intelligence individually relatively the same way. What this basically means is that all the Shakiras, they don't value power, money, appearance, and intelligence the same way, and all the Donald Trumps relatively do not value power, money, appearance, and intelligence the same way. Now, using the PBG function might be a very quick way to test for the parallelism and the flatness of the results for the profile analysis. But let's say these aliens are not satisfied with the PBG function. They think that, oh, this function was made by humans. How can it really be that perfect? And we can see that, you know, the graph that you generate, the legend covers some of the data points. So this package is not perfect. We want you to do all the tests using statistics, using simple codes rather than this package. Then how will you do it? Now, because you are very good at R and you're very familiar with the RStudio environment, you know that there is a way to do that. And in order to do that, we need to do the entire test all over again by using a different method. So using this different method, what we need to do is we need to calculate the means for each of these outcome variables for each of the different clones. So what I have here is I took the data from the profile data frame. I took out the data for all the Shakira clones, and here I took out all the data for the Trump clones, and here I took out all the data for the Dr. Phil clones. And using this line right here, I can calculate the means for the how much the Shakira's value power, money, appearance, and intelligence, and same for the Trump's and the Dr. Phil's. So I can just run these 6 lines here. Great. So now I can create another vector which contains these 3 names for the 3 types of clones, each 4 times. So I just run. Now for this line right here, what I did with this line is to put the values for the means for all the Shakiras, all the Trumps, and all the Dr. Phil's into one single vector. Run this line right here. Now, so for this line, what I'm doing here is I'm using the repeat function to make a vector that has power, money, appearance, and intelligence as string entries, and each of them will be repeated 3 times. And this vector is assigned to the name outcomes. And this repeat is actually very different from this one. For this one, you will have the pattern of Shakira, 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 4 Shakiras, then 4 Trumps, and then 4 Dr. Phil's. But for this one, we have power, money, appearance, intelligence, then repeat power, money, appearance, intelligence, then repeat again, power, money, appearance, and intelligence. Now this line, it uses the data frame function to put the type of clones, the means, and the type of outcomes together in a single data frame. Now, I assigned this data frame the name of mean data frame. If we take a look at mean data frame, so if we take a look at the mean data frame, we can see that we have the means for all the outcomes, all types of outcomes, and also it's labeled by the type of clones that this means was taken from. So this right here is for the means of how much all the Shakiras on average values power, and this one is how much all the Shakiras overall values money. So now if we want to build a profile graph from scratch, instead of using that PBG function that the aliens don't like, we can use the GGPlot function. Now, sorry about this, but I forgot to read the GGPlot function into the environment, so I'm gonna do that right now. And the package is actually called GGPlot too, but the function itself is just called GGPlot. And if you haven't installed it yourself, you can just use the install packages and put here, instead of profile R, put GGPlot 2. And we can use GGPlot to build the profile graph. And using this, the GGPlot function, the first entry, of course, is the mean data frame right here. And with aesthetics, for the x-axis, we have the outcomes right here. And for the y-axis, of course, we have the mean scores, which in this case, the column's name is means. And for the group variable, of course, it's the type of clones, which is this column here. And also, this is going to be a line graph. So for aesthetics, we try to state that this is going to be 3 different lines, and we can do that by specifying that we want each line to be each type of entry in the clones column right here. And also we label the axis, the x-axis is the outcome variables, and the y-axis is the mean value scores. Now, so for this graph, we assign it the name profile graph. Now, if we want to take a look at the graph, we just take the name of the graph and we run the line with the name by itself. Now let's take a look at the profile graph. Now I know that this profile graph, it doesn't look the same as the previous one, but they are indeed the same graphs. It's just that for this one, we have power, money, appearance, and intelligence in this order. But in the other graph, the different outcomes are in a different order. So they are in alphabetical order: appearance, intelligence, money, and power. But they are the same graphs. And as you can see, you can also tell from this graph that the parallelism that we can tell from our naked eye doesn't exist, and the flatness, of course, is also not here. And also this graph, what's good about it is that the legend is something that we can customize very easily, and it doesn't cover any of these points. Now, let's say if we want to do the parallelism test, how do we do it without that PBG function? Now, it's actually very simple. The parallelism test is actually So how do we perform the test of parallelism from scratch? So we can do that by first using the attach function on the profile data that we used in the beginning. This way, once we do that, we can just call on the variables in this data frame without having to specify that these variables came from this data frame. So before we can do the parallelism test, we need to take the difference between each of the columns in the profile data frame. So if we want to take the difference between power and money, we can do it like this: power minus money, and assign it to the name PM. And the same thing with money and appearance, and the same thing with appearance and intelligence. So now what I'm going to do right now is I'm going to take the names column and these three separate columns that I just created and make them into a data frame and assign it the name diff, as in difference. So why did I take the differences of the value columns from the profile data frame? The reason that I wanted to do that is because in order to do the test for parallelism, the test is essentially just a one-way maneuver of these difference outcomes. So these three different columns here, and also the names variable. It's just a one-way maneuver of these. So in order for us to perform that, we need to first read in the mass package. And the mass package is where the MANOVA function comes from. And we run this options SciPen equal to 999 here so that our values from this test will have decimals. So now what we do is that we create another different data frame. So what we can do is we can put the PM column, the MA column, and the AI column together as a data frame and assign it the name outcome. So if we were to go to outcome here, we can see that it has 3 different columns in this data frame. But these columns they represent the differences of the power minus money, the difference of the scores between power and money into one column, and the difference between money and appearance in the next column, and also the difference between appearance and intelligence in the third column. So now we can work with this outcome data frame, and we also use the function factor on the names so that we can make sure that it's treated as a categorical variable. So we insert the outcome data frame that we just created as the outcome variables in the MANOVA, and the names as the independent, and we just run this model right here. And after we finish running it, we can get the information for the 4 tests that were performed in the MANOVA. Like for this one, it's for Wilkes. The next one is for Pillai, and the third one is for Hotling Lolly, and the fourth one is Roy. And the results from this one should be exactly the same as the previous one that was performed with the profile R package using the PBG function. These values, they should all be the same. And as you can see that if we look at the p-values, we can still reject the null hypothesis that all 3 different types of clones have parallel profiles. So I hope that's clear. So now that we are done with the parallelism test from scratch, we can now take a look at how to perform the flatness test from scratch. In order to do that, we need to use the ICSMP package. Now, you probably think this package is kind of familiar. Well, this package, I actually talked about it and used it in the very first video of this series on Hotling t-square test. So if you want to understand about this package better and also understanding the Hotling t-square test better, I strongly recommend you go to the first video of this series and rewatch it. So I already have this package installed in my R environment, so all I have to do is open it using the library function. So what the flatness test essentially is, it's actually something called a one-sample Hotling test that needs to be performed on sections of the diff data frame for each kind of clones. So as you can see we can see that it has these 3 columns for the differences of the attitudes that these 3 different types of clones have for power and money, money and the physical appearance, and appearance and intelligence. Now, as you can see from this data frame, the first 5 rows are the Shakira clones, the next 5 rows are the Donald Trump clones, and the last 5 rows are the Dr. Phil clones. So essentially what we're trying to do is to perform a one-sample Hotling test on each of these sections of this div data frame, and just to see how each of these different types of clones, the means of the differences of their interests for these four outcome variables, how far are they from the zero mean? So why do we need to do this? It sounds very complicated, but it's actually not. So let's take a look at this profile graph again. And let's say we look at the Shakiras. If we want to look at the flatness of the profile for all the Shakiras, let's say if this profile is flat, then the differences between the power and the money would pretty much be zero. And also the difference between money and appearance would also essentially be zero. And also the difference between appearance and intelligence, they should also essentially be zero. So we just want to look to see if the means of these differences for all the Shakiras, are they close enough to zero to be statistically significant or not? And it's the same for the Trumps and the Dr. Phils. So in order to perform this test, we need to run these three lines. And of course, the Hotling's T2 function comes from the ICSMPR package. And these entries, they are just a way for me to slice the data from the div data frame for all the Shakiras, all the Donald Trumps, and all the Dr. Phils. Now, if we want to look at the outputs of all three of these, we just need to put the names from these three and run them individually. So we can see from these tests, and we can see from the p-values. What I just ran here are the results of the one sample Hotling test from all the Shakiras. And of course, the null hypothesis in this situation is that the means for all these differences are all close to zero. So the line is supposed to be flat. But of course, that's not true. And from the p-value, we can reject this hypothesis because it's lower than 0.05. So what this means is that the Shakira clones, they don't have a flat profile for each of these four values, which means that all the Shakiras, they don't value these four things equally. And if we were to do the same for all the Donald Trumps and all the Dr. Phils, let's run Trump here. We can reject the null hypothesis also. And we can also see from this graph, of course, as I said before, using the PBG test, the line is not flat. And from the p-value, we can reject the null hypothesis that the line is flat. And it's going to be the same with all the Dr. Phils. As you can see, the p-value is also lower than 0.05. So at the 95% level, we can reject the null hypothesis that Dr. Phil values power, money, appearance, and intelligence equally. We can reject that null hypothesis at a statistical level. Okay, so that's it for profile analysis. I've shown you how to do it quickly using a package, and I've also shown you how to perform it essentially from scratch, but we also need some R packages and R functions in order to do that. So I hope that this video is very clear for explaining this topic. And if you have any suggestions on how I should make my videos in the future, please feel free to leave me a message in the comments section. Thank you, and please stay safe in this pandemic.